Anytime you have a polynomial, there's no even root, there is no rational function. What's the domain? All real numbers. Here we have an even root. What do I know about x minus 1? It has to be greater than or equal to 0. Therefore, the domain of g of x is x such that x is greater than or equal to what? 1. Okay, so let's first start by finding the composition here. We're finding f of g of x. So I'm going to rewrite my outside function as parentheses squared plus 1. What is going into the parentheses here? Root x minus 1, g of x. So I'm going to take my g of x and I'm going to plug that in. What happens when you square a root? So we have x minus 1 plus 1. Therefore, my composite function here is x. So the constant terms cancel each other out. We're left with x. Here's the thing. The domain of x is all real numbers, no restrictions. However, I'm doing the domain of the composite function, and what does that mean? Yes, excellent. We have to use the domain of g of x. So even though this is all real numbers, I was never able to plug in anything less than 1. All right? I can only have x greater than or equal to 1. So here is our domain. Here is our composition. All right? So for g of f of x, for g, I have the square root of parentheses minus 1. What goes inside the parentheses here? X squared plus 1. So then I'm left with the square root of x squared plus 1 minus 1, which is the square root of x squared, and therefore g of f of x equals x. All right, what was the domain of f of x? It was all real numbers. So I plugged into my function every x worked. And then I got my composite function, and guess what? It's all real numbers. Everything works for x. There's no restrictions. So here the domain is just all real numbers.